Good morning, Cappuccino. Shout out to last night's winners. Oh, actually, I think I already did that in the warm-up video, so never mind. Today's winners, I still have a little more space to give out some extra credit. I've already gotten one correct solution, but I'm waiting for some more. So go ahead and keep working on that warm-up. Okay, so today we are going to be looking at binomial distribution like we were doing before with the last math space assignment where we were using Pascal's triangle to figure out the probability of a particular outcome given a number of trials and how many successes we wanted. But there's actually a way of doing this with a formula. So in the formula packet, if you look under statistics and probability, you'll see down here binomial distribution. You'll notice here expected value, which is today's warm-up. We have this formula, which is in our notes. Looks something like that, I think. But now we're going to be adding this one now, binomial distribution. Look at this crazy stuff. It's like, what does this mean? So we're going to be going over this right now. Okay, so I already wrote down some of it to get a head start, but now I'm going to explain what this is saying. So, first of all, you got to know that you have an event that is distributed in a binomial way. Okay, so if we look back at our notes, our last notes, we talked about binomial distribution. There has to be two possible outcomes. Either it happens or it doesn't happen. Okay, you can't do this formula with stuff that doesn't follow that rule. The trials have to be independent of each other, and the probability of success has to be the same after every trial. Okay, so there's really strict rules. The probability cannot vary from trial to trial. It has to stay the same, and the events have to be independent of each other. Okay, so here we go. This formula right here, what this is saying is it's saying that the event, okay, X is our event, the event that is distributed, this means is distributed as a binomial. Okay, so this part right here is saying the event that is distributed as a binomial. The event that is distributed as a binomial. Okay, that means there's only two possible outcomes. Either it happens or it doesn't happen, right? Two possible outcomes means binomial. There's only two, bi means two possible outcomes. Okay, so the event that is distributed as a binomial with, this would be number of trials. So, for example, you flip the coin 10 times, okay, how many times you're doing the event, and this would be the probability of success. P is the probability of success. Okay, so if you know the number of trials you're going to do and you know the probability of success for a single trial, we can then use this formula. Okay, so what is this formula saying? So this is the probability of the event happening, and this is number of times we want it to be successful, so the number of successes. So N is the number of times you do the event, and R is the number of times that you want to be successful. So for example, if I'm flipping a coin 10 times, N is the 10 times I'm flipping the coin, and let's say I want to get heads 7 times. If I want to get heads 7 times, then R would be 7, okay, because that's how many times I get heads. So let's go ahead and write down what these are. Okay, so R is the number of successes. Okay, we already said N is the number of trials, and R, we just said, is the number of successes. Now, probability, we already said what that is. That's the probability of success. Okay, so let's look out at this now as three separate parts. If we look at this part right here, this is the coefficient of our problem that we were getting from Pascal's triangle. And some of you, when you were sending me your warm-up, you recognize this The thing from Pascal's triangle is also you can get that using the combination formula, which we're going to look at in a minute. Okay, but the way I showed it, just doing it sort of the intuitive way, we got this from Pascal's triangle. Pascal's triangle. But it is also possible to get this from the combination formula. So you can get this from Pascal's triangle or the combination formula, which I saw some people were using. So I'm guessing people who took Algebra 2, maybe you already knew that, or maybe you looked it up. Okay, and that's this formula down here. Okay, it's also called the binomial coefficient because this is the coefficient of our binomial probability. Okay, and then the next part, this part right here, this is our probability of success. Okay, our probability of success raised to how many successes we want. Okay, so this is our probability of success. And this part right here is our probability of failure. This is our probability of failure. Okay, raised to the exponent of how many failures we want. Okay, so we are going to have a look at the warm-up from yesterday. Anyway, I'll show you what warm-up I'm talking about in a second. And we are going to apply this formula to our warm-up. All right, I did want to mention this coefficient, the binomial coefficient. There is a formula for this, and here it is. This is also in the formula packet. So this is back on like the first page, right here, binomial coefficient. So n trials and r successes is n factorial over r factorial times n minus r factorial. Okay, so I'm going to show you how we're going to use this on our warm-up from yesterday. Okay, so let's look at our warm-up from yesterday. We are going to have a look at that, and then we're going to do it using our formula. So, looking at our warm-up from yesterday, on a television channel, the news is shown at the same time each day. The probability, that Salia watches the news on a given day is 0.35. Okay, so my P is equal to 0.35. And we're going to calculate the probability that on 5 consecutive days, she watches exactly 3 days. All right, so that means our N, our number of trials, is 5, and our R, the number of successes, is 3. Okay, so we're going to use this information now. This is the information I got from my warm-up. I'm going to use that in my formula. So now I'm going to go back to my notes, and we are going to go ahead and use this in the formula. So our example is going to have a probability that's equal to 0.35. The number of trials is going to be 5, and the number of successes we want is 3. We want to know what is the probability that she will watch 3 days of news out of 5 days. Okay, so if we were doing this the intuitive way that I had already shown you that we were using on MathSpace 2 days ago, because yesterday I was not online because my power went out, we would have used Pascal's triangle. We would have said, okay, I have 5 trials, and I want the third one on the row. All right, so 5 trials. So 0, 1, 2, 3, 4, 5. Here's 5 trials. This would be all of them were successes, 4 of them were successes, 3 of them were successes. So my coefficient would have been 10. Okay, so from Pascal's triangle, I would have had 10. And then, the way we were looking at this, we multiplied by the probability of getting successes. So we would have done 0.35. And how many times do I want to be successful? 3 times. And then I would have multiplied that by the probability of having a failure, of not being successful, which is the complement of 0.35. The complement of 0.35 is 0.65, because those have to add up to 1. 0.35 plus 0.65 is equal to 1. Okay, another way of getting that, where's my calculator? I'm like buried alive in papers here. So 1 minus 0.35 is 0.65. Okay, and how many failures would I have? Well, if I have 3 successes, then I have to have 2 failures because there's a total of 5 trials. So this is how we were doing it from 2 days ago, sort of doing it by intuition, by looking at a pattern and figuring out the pattern and just intuitively doing it. Now, how does this relate to the formulas? How does this relate to the formulas? So the 10 here, that is the binomial coefficient. So that is my NR. Okay. The next part, this part right here, that is my probability of success. So that's P to the R. And here's my probability of failure. And to get that, I did 1 minus P to get the complement. And then 2 was the remaining trials, the failure trials. So that is the 5 number of trials minus, oops, sorry, I meant to write N. Gosh, I was doing so good. All right, that's to the N minus R. Okay, so that's the exponent N minus R. Don't do the scribble like me. That's so annoying. Where's my whiteout? Let's see if my whiteout will work. No, yesterday the power goes out. Now, does my whiteout work? Yes. Let's white that out. I don't want that. All right, 1 minus P to the N minus R. Okay, so what we were doing intuitively actually matches up with the formula. All right, now what if I wanted to calculate this without using Pascal's triangle? Because imagine I had 20 trials. Holy cow, if I had 20 trials, look how big this Pascal's triangle was for 9 trials. If I wanted 20 trials or 100 trials, Pascal's triangle gets ridiculous. I don't want to use Pascal's triangle anymore. Okay, I was just using Pascal's triangle to show you, that we recognized a pattern and we can use that pattern to help us. But now let's go ahead and use a formula. So the formula for N over R, we wrote down over here. Here it is right here. It's N factorial, the number of trials factorial, over the number of successes factorial, times number of trials minus the number of successes factorial. So let's go ahead and calculate that. So we're going to do it without a calculator, and then I'm going to show you how to do it with a calculator. So without a calculator, because you will be asked, on the, if we ever take the IB exam, don't ask me when we take the IB exam, there are questions without a calculator and there's some with a calculator, so it's important to be able to do these both ways. So we're going to calculate NR, okay, the combination of N objects taken R ways. That is going to be, for this particular case, our N is 5 and our R is 3. Okay, so now I'm going to plug it into the formula. So I've got my formula on my formula sheet. So if you were like taking the test, you would have your formula sheet. So here it is, right here. I would look at that and I go, okay, N factorial, so that'd be 5 factorial over R factorial times parentheses 5 minus 3 factorial. Okay, so now we're going to write it out and we're going to reduce it. So 5 factorial means 5 times 4 times 3 times 2 times 1. And in the denominator, 3 factorial is 3 times 2 times 1. And then 5 minus 3 is 2. So 2 factorial would be 2 times 1. Okay, and it's all being multiplied together. Don't put any plus signs in there. I know some of you are going to want to put plus signs. There aren't any plus signs. Okay, now we can reduce it. 1 divided by 1 is 1. 2 divided by 2 is 1. And I have a 3 divided by 3 is 1. Let's go ahead and see what I have left right now. 5 times 4 is 20. 2 times 1 is 2, which equals, what do you know? It equals 10, just like we had there. Okay, so then at this point, I would have this, and I would not want to multiply this out by hand. This, if I was not allowed to use a calculator, I'd probably just leave it. Hopefully, if you're doing this without a calculator on the test, they'd give you nice simple ones like fractions, like 1/4 and 3/4 and small numbers, right? But this we would definitely do with a calculator. Okay, so let's go ahead and answer this. So I'm going to have 10 times 0.35 to the third times 0.65 squared. I'm going to put all of that into my calculator. Let's just pretend I did, because because I did it earlier, and I have to round it off, but I get approximately 0.181. So that was the answer to the warm-up from yesterday, 0.181. Okay, where we had a probability of 0.35, 5 trials, and we wanted 3 successes. That was the answer to that one. Okay, so there is, though, a faster way of doing this on the calculator, but I know we've been learning how to do a lot of stuff on the calculator, and so sometimes it's easy to forget what you did on the calculator. So this, I went through it this way, showing you this is kind of the long way of doing it, just so that you realize that we can do this whole problem, we can do this whole formula without remembering where anything is on the calculator. We can just do it by using formulas. But now let's go ahead and see how would we do it if we did it with a calculator alone. Okay, and we didn't use, we didn't like write it all out exactly. Okay, so with the calculator will actually do the whole thing for you. You don't have to do any work whatsoever. So with the calculator, first of all, there's 2 things you can do. First of all, if you just wanted to find the NR, okay, if you just wanted to find this, the binomial coefficient, okay, just the binomial coefficient, the way you find that is you press Math, and then you go over to Probability, and it's the 3rd one down. Okay, so I'm going to write that down. If you're just trying to find the coefficient, the binomial coefficient, if you just want the number that we took from Pascal's triangle, if you just want to find that, it's Math, and then Probability, and then 3, select option 3, which says NCR. And then when you select that, it asks you what's N and what's R. Okay, if you have the TI-83, I don't know what it shows. You're going to have to play around with it. And I unfortunately did not bring an 83 home with me, so I can't play around with it, for you. All right, so N, if we looked at our problem from before, the example we were doing, so from our example, we had N was 5 and R was 3. So if we put those in, I put in my 5, and then I put in my 3, and when I hit enter, it should give me 10. Yep, there it is. Okay, so that's just finding, here, let me write out what it showed on the screen. That's just finding the coefficient. All right, so from this example right here, to get that, we could use the formula, we could write it all out, or you can use the shortcut on the calculator, which is Math Prob option 3. Okay, so if you forget how to do this, you can always go back and just use the formula because this is in the formula packet. That's why I'm showing it both ways. Now, we could do the whole thing all at once, or the whole thing. We can get the entire answer, okay? We can get the whole answer at once. So remember, our formula is N over R, that's the coefficient. Here's the probability of success times the probability of failure. Okay, this guy right here. We can get this whole thing at once. But if you are doing this on a test, you need to first write this out with all the proper numbers before you start typing it into the calculator. So you would need to set it up. Okay, so for our example, this would be 5 over 3, 0.35 to the 3rd times 1 minus 0.35 to the 5 minus 3. So I would expect to see this much written out on the test before you start poking the calculator. Okay, now, to get this whole thing into the calculator, the way that you do it is you are going to hit second, and then vars. All right, and the reason why we're doing second vars, second, and here's vars, is if you look in blue above it, it says distribution. Distribution. Look at that, distribution. What kind of distribution do we have? None of these. We have a binomial distribution. So I'm going to go down to option A. So keep going down. There it is. We have a binomial distribution, probability distribution function. BINOMPDF, binomial probability distribution function. That's what we've got here. So it's option A, and it says BINOMPDF, binomial probability distribution function. That's what it stands for. And if we select that, check this out. I already entered in my numbers, so let me actually, these would not be in here. Shoot. So, sorry about that. Let me do that again. And I'm going down to option A. There we go. Now they're all clear. Okay, so this comes up. So trials is going to be 5. That's our N. Okay, so we're going to put in 5. P is our probability, so we're going to put in 0.35. X value, the X value is the number of successes we want. So that is, for this problem, is going to be a 3. And then we hit enter and enter again and enter again. Keep hitting enter until it gives you the answer. And there is the answer, just like we got when we did it by hand, approximately 0.181. All right, so let's write down what happened. Once we got here, it asked us to fill in the number of trials. The number of trials was 5. It asked us to write down the probability. The probability was 0.35. And it asked us for X value. The X value is the same thing as R. Okay, that's the same thing as R, and we wrote 3. Okay, so the X value, this is R. That's our R. All right, the probability is P, and the trials, this is our N. And then you get your answer, lickety-split. All right, so we are going to do more complicated problems where it asks you for a range of values, but I'm not going to cover that right now because I'm over my 20-minute time limit that I was hoping to set for myself. So I'm going to set up now a math-based assignment where you're going to be just doing it on the calculator. So you can do it this way using these buttons, or you can do it just by using the NR, use the NR, or you could use the binomial coefficient formula. Okay, so you can do it the long way, the sort of short way, or you can do it the super short way. All right, I'll leave it up to you. The more you practice with the calculator, the more natural it'll get and the more you'll be able to remember it. All right, so good luck. Feel free to send me emails anytime you get stuck. Don't sit there, just like hitting hint, 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 hint on MathSpace. I'm just sitting at home making videos. So reach out. Get some help if you need it. All right, take care. I hope you're all doing well. Miss you a lot. Bye-bye.